Okay, in this video we are going to go over problems 16 through 20 from the January 2018 Geometry Regents exam. All right, so looking at problem number 16, there are obviously some notes that you see that I'd like you to write. Okay? And let's look at the question. All right, it says, let me get the highlighter out. It says, in circle and below, diameter AC, chords AB and BC, and radius MB are drawn. Which statement is not true? Okay, in order to do this question, there's really a couple of vocabulary words that you're going to need to know and be able to define. And I always tell my students, when you're looking at a question, look at the vocabulary. What does it mean? What does it tell you? All right? So a couple things I want you to write down. First of all, what is a chord? Well, here's a chord. So if you're in my class and you want your extra credit, you need to write down these definitions. So a chord of a circle is a straight line segment whose endpoints lie on the circle, whose endpoints both lie on the circle. And I have a picture here of a chord. And as you can see, that fits the description. The endpoints both lie on the circle. A diameter is actually the longest chord of a circle because it goes through the center point. So it actually is a chord technically. All right. The diameter, which I don't have up here as a definition, but when you see diameter, that's going to be AC, and they tell you that it's AC there. All right. Now, in a radius, MB, so radius from here, so M to B here to there. All right. Now, a couple things that you're going to need to know. What is an inscribed angle and what is a central angle? So an inscribed angle. Because as you look at this diagram, there are inscribed angles and there are central angles. So an inscribed angle is an angle with its vertex on the circle. So for example, let's look at one of these that is an inscribed angle. All right, so inscribed would be, for example, BAC. Okay, this is an inscribed angle with its vertex, which would be A, on the circle, formed by two intersecting chords. The intersecting chords would be AB and AC. All right? Now, when you have that, the measure of the angle is half. So I'm circling this right here because that's going to be important. The measure of the inscribed angle is half the measure of the arc that it cuts. So when you have this angle, BAC, that's going to be half of the measure of the arc that it cuts that I'm outlining in blue. So if we could figure out what this blue part is, this angle up here would be half. That would be half of this. Okay? All right, so let's look at another inscribed angle that we see. We have another inscribed angle, which is ACB. So it's the same thing. This angle is half of this arc. All right, so the measure of that angle ACB is half of the arc that it cuts. All right. Then we also have a central angle. Central angle. So that one, highlight it. It's an angle formed by two radii with a vertex at the center of the circle. All right, so looking here, where are our central angles here? Well, let's look at the definition. Angle formed by two radii with the vertex at the center. All right, so two radii. So what's one? Here's a central angle right here. Central angle, central angle. And let's see, if you look here, the central angle in this case, or always, the central angle is equal to the measure of the arc that it cuts. So this angle and the arc AB, are actually going to be the same measure. The same measure. So you have a central angle there. You also have a central angle BMC. That's also a central angle. So that angle measure is the same as this arc. Okay? All right, so I just want to look at a website really quick that's got some information. So I was here. So here is an example. Okay? If you look here, you see that we have a measure here, and I can't write on this. However, you can see that we have a measure, so I'll move the cursor here. We have a measure of 82 here, and that means the central angle will also be 82. All right? Now, if we go down, inscribed, so we have an inscribed angle, which I described to you, and you have the measure out here of 82. That means x will be half of that, which is 41. Okay, and we saw that. All right, so let's go back here. And now let's look at the question, look at the answer choices. It says, which statement is not true? Okay, which statement is not true? So A, B, C. So think about that. If it says which statement is not true, that means that 3 of them are true. 1 of them is not. So what about A, B, C? Is that a right triangle? Well, let's look here. We have A, B, C. That is an inscribed angle. And it actually, we know that this is a diameter here. So that means that this part I'm outlining in green is half of the circle. So that means that is 180. And remember, with an inscribed circle, which I'm circling in green, the measure of this angle here is half of the measure out here. So that means that this is 90, which means that this is definitely a right triangle, which means that is a true statement, and that is not our answer. Okay? Now let me erase this. Now it says, what about triangle ABM? Is that isosceles? So ABM, so let's outline that. A to B to M. All right? Is that isosceles? Well, remember, BM or MB is a radius. MA is also a radius. Those two sides are the same. Remember, isosceles triangle has two angles that are the same. I'm sorry, two sides and two angles that are the same, which means that that is a true statement. That's not my answer. All right, now what about the next one? What about the measure of arc BC? Is that equal to BMC? All right, so let's look here. BMC is a central angle, which means it's equal to the measure of this arc, because that's a central angle. We talked about central angles. So that means that this is true. The measure of arc BC is equal to the measure of this angle. So that's true. So that means that our answer is number 4. Okay, let's look at what number 4 says. It says the measure of arc MB, so MB, where's AB, I'm sorry, AB, is equal to 1/2 of the measure of ACB. So where's ACB? Well, actually, that should be the other way around. The measure of angle ACB is actually half of the measure of the arc of arc AB. So it should be the other way around. That's why that is not true. That's why that's our answer. Okay, let's look at problem number 17. All right, problem number 17. It says, in the diagram below, sides XS and YR intersect at Z. Segments XY and RS are drawn perpendicular to side YR to form triangles XYZ and SRZ. Okay, now, it says, which statement is always true? So first of all, I want you to write this down, because this is very important to this. These triangles are similar by angle. All right, the reason why we know they're similar, is because they give us this piece of information, the fact that segments XY and RS are drawn perpendicular, so that's XY, that's this angle here, and RS are both drawn perpendicular to YR. So that means that this angle and this angle are both right angles. We also know that this angle here that I'm outlining are equal or the same measure because they are vertical. So that means by angle, we know that these triangles are similar. Now, we don't know that they are congruent. And that's a problem or a mistake students make is they think they're congruent. Well, we don't know that they're congruent. I mean, you can look at the picture and say, well, they look congruent, but we don't ever look at diagrams that way. We look at what we can prove, and we can prove that they are similar. All right, so let's look at which statement is always true. So what I'm going to do now is I'm going to outline the sides that are the same, and we're going to see, maybe that'll help us. So, not the same, but that are corresponding, I should say. So we have xy and rs. Then we have rz, and yz. And then we have x, z, and s, z. All right? Okay, so now it says which statement is always true. So what about the first one? Is that statement always true? Is xy, so xy times sr, so xy, I'm sorry, well that was wrong. Let me erase those marks. Okay, xy times sr, okay, those are corresponding, that's good. And we went from the left to the right. So xy times sr, is that equal to xz? So that would be xz here times rz. And that is not good because that's not corresponding to xz. So that's not going to be a true statement. That is not going to be a true statement. Right? Not always going to be true. They're asking what will always be true. All right? So that's not right because it wasn't using corresponding sides. All right? So let's go to the next one. Is triangle XYZ congruent to triangle SRZ? We already talked about that. No way that we know they're congruent. What about XS is congruent to YR? All right, XS is congruent to YR. Well, again, there's nothing in this problem that tells us why these two, so XS would be this one, and YR would be this one. There's nothing in the information or in the diagram that would lead us to believe that that's always going to be true. Now, it might be true in certain cases, but there's nothing in here to let us know that's always going to be true. So our answer is number 4. And let's just look really quickly at y. All right, we'll move a couple of these things over here. Now it says that xy, so xy is going to be this piece over here, times SR, corresponding, good. I'm saying not times, over. So xy over SR is equal to yz, good. We're on this left triangle first, over RZ, which is corresponding. That's all good, okay? All right, so our answer is 4. Okay.
Will Cambrion Morgan please report?
All right, so on this problem, again, let's look at the information that's given. We know, based on what I just circled, that these lines are parallel, because that means parallel, right? So they're parallel here. Let me write that down. Right? They're telling you that for a reason. When you know lines are parallel and you have lines going through, that means that you have alternate interior angles are congruent, your corresponding angles are congruent, your same side interior angles add up to 180, alternate exterior possibly. All right, so just keep that in mind. Then it also says BF is congruent to EF. So that means that this triangle in here is actually an isosceles triangle. And the base angles, the ones that are congruent, are down here because they're opposite from the sides that are congruent. So keep that in mind. Now, it says if angle CBF is 42.5. So let's label that. CBF is 42.5 degrees. And we're looking for EBF. So EBF is going to be right here. All right, so let's go through the reasoning that we're going to use as we do this. All right, so we have a lot of different things, but the first thing I would look at is we have the z-test. I always say z-test because z-test when you have two parallel lines and you have a third line, right? So z-test is going to be, let's see here, z-test right here. So that means these two angles, this one and this one, are the same. So that means that this is 42.5, all right? And let's see, so we know that. And let's look at the diagram and see what else we know. Okay, so let's look. So we have this triangle here. So I have this triangle. I'm going to outline this in black. I'm going to try and move this over. And I'm going to move this over. Now, so if you see me moving it, you know that one of the angles we know. We know that this angle is 42.5, which would not help us. However, we know that the other two angles have to be the same. And we also know that all three angles have to add up to 180. So what we can do is 180 minus 42.5. Right, so let's go ahead, get your calculator, and 180 minus 42.5. So that means the other two angles have 137.5 degrees. Now, we only need one of them though. We don't need both of them, so don't put number 4. So what you now need to do is divide that by 2. So I'm going to divide that by 2, and you get 68.75. So this is equal to 68.75. All right? All right, problem number 19. It says a parallelogram must be a rhombus if its diagonals are blank. Now, one thing I will say is that they often ask you about parallelograms and knowing about the diagonals, because the diagonals of a rhombus have different properties than the diagonals of a rectangle, okay? So, and for some reason, I've seen that a lot. Just you have to know about the diagonals, So, let's look at the options. It says are congruent, bisect each other, do not bisect its angles, are perpendicular to each other. All right, so this is definitely going to give it away, but I want you to write down these notes about the diagonals of a rhombus. They bisect the opposite angles, okay? And the diagonals are perpendicular, which means they form 90-degree angles. Okay, so based on that, we know our answer is number 4. Before I move on, just to let you know, a square is actually a special type of rhombus. Not every rhombus is a square, but every square is a rhombus. Okay, same thing with rectangles. Not every rectangle is a square, but every square is a rectangle. Okay, so that's your answer. You need to know the properties of parallelograms. Every parallelogram has 5 properties that I talk about, and then once you get into more specifics, like the rectangle, the rhombus, and square, you get more specific properties. But so that's it for that. Okay, looking at number 20, it says, what is an equation of a line which passes through the point 6, 9 and is perpendicular to the line whose equation is 4x minus 6y equals 15? So the first, couple things. Let's notice, is perpendicular. So we have to keep that in mind, a line that's perpendicular to another line. All right, and goes through the point 6, 9. So the first step I would say is let's take this equation and let's put that in those slope-intercept forms so we can easily identify the slope. So I'm going to just move the 4x to the other side. So that's going to end up being, we're going to end up having negative 6y is equal to negative 4x plus 15. Then I'm going to divide everything by negative 6. Divide by negative 6, and you end up with y is equal to negative 4 divided by negative 6 is positive 2/3, and then the y-intercept really doesn't matter in this case, but that's going to be 15 over 6. Let's reduce that. That's going to be 5 over 2. It's going to be negative, right? So negative 5 over 2. Let me write that again. All right, so y is equal to 2/3 x minus 5 over 2. So the slope here is equal to 2/3. Now, the thing is, when you have a line that's perpendicular, if you're looking for a line that's perpendicular, the slope has to be the negative reciprocal. So what is the negative reciprocal of 2/3? Well, it's negative 3 over 2. That's the reciprocal, that's the negative reciprocal. So any line that's perpendicular to this line right here, it's got to have a slope of negative 3 over 2. All right, so if I look at my answer choices here, I have 4 answer choices. These answer choices are all in point slope form, which depending on, if you're in my class, depending on when you watch this, we haven't gone over this yet, but if you're just reviewing and you're in, just watching it, maybe you know what that is. But whenever you have an equation in point slope form, the slope can be seen right on the outside of these parentheses. All right, so that means we can eliminate 2 of them. 2 and 4 do not have the slopes that we need. 1 and 3 do. Now the question is, which one of those pass through the point 6, 9? Well, any number of ways you can do this, but I would, for our purposes now, I'm just going to plug in the 6 for x and the 9 for y and see which one works out. So let's go to number 1. I'm going to plug in, remember you have x, y. I'm going to plug in 9 here, and I'm going to plug in 6 here. Do the sides equal each other? Well, 9 minus 9 is 0, negative 3/2, but in the parentheses you're going to get 0. Negative 3/2 times 0 is 0, so that means 0 equals 0. That means that point is on that line. Now, if you do the same thing on the other side, if you plug in 9, then you plug in 6, you end up with 18 on that side, and then you end up with negative 3/2 times 12, which is definitely not 18, so that's not your answer. Okay, so there we go. That's problems 16 through 20. I'll be going over the other ones later on in the week.